Okay, so I want to discuss with you some potential date for our replacement class. We can do on weekdays. Okay, so we have like around from today. Wait, from today it is maybe we start from 29th of January. Okay, I'm quite free because my current university is already in semester week. Okay, so we have to decide whether starting from 28th of January before the Chinese New Year, okay, which is like around 9 to February. Okay, we can do on weekdays. Okay, so on this replacement class, I will do a midterm exam. Okay, 1 hour class and followed by 2 hours midterm exam. So we need around 3 hours. Okay, we need around two hour and a half and 3 hours. Okay, so actually I want to do using my Teams and also my Google Meet. Okay, but because I'm part-timers or because of like they asked me to do the class, okay, via Zoom, they will set up for us. Okay, they will set up. I hope that this time around there will be no issue. Okay, so everything we do like okay, everything we do this we're going on like schedule. Okay, because we know that we cannot do our class on 9 and 10 because it's we have to respect our Chinese friends who want to celebrate for Chinese New Year. Okay, so we can do on weekdays. Okay, please discuss among yourself. I can do on weekdays. Okay, I think most of you are working. Okay, so we can do on like after evening. Okay, maybe we can after evening. Okay, if you're not free for 3 hours, okay, maybe we can split. Maybe we can split to compression. We can split into 2 sessions. Okay, one for midterm only and one for class. Okay, so please discuss among yourself. Okay, so and okay, after this class, I will give you another task. Okay, last week we do short quiz. Okay, I received like at that time I was quite busy. Okay, so I received a lot like for the question 8 already. But if anyone have any issue, okay, please reach to me. Okay, some of you I already noticed that I cannot read their data. Okay, and they have approached me. Okay, and question 1. Okay, yeah, I will check it. Okay, so Mu'min and one shipping. Okay, Mu'min and one shipping. Okay, I will check your question 1. So far, I checked. Okay, so far I checked. There's no like issue for question 1, but let me check again. Okay, so far there's no issue with question 1, but let me check again for that. Okay, and okay, for your midterm, okay, we will do during the weekdays. Okay, so we need 3 hours for this. Okay, 2 hours for your midterm and 1 hour for your class. Okay, we can do on separate day. Okay, I'm very free. Okay, I'm very free. So I pass the baton, okay, the freedom for you to decide. Okay. And on weekday, on 11, so not 11, wait, let me check on 12. 12, I think. Yeah, on 12th of February, I will release your final assessment. Okay, I will release your final assessment. Then I will give you all your assignment has been already graded. Okay, but I want to review it again. Okay, before I email you. Okay, so let's look at chapter 4. Okay, let's look at chapter 4. Okay, so okay, this is actually data mining, but using image. Okay, we call it as object classification, which is the application of neural network, one of the application of neural network. Okay, this is actually a part of spatial statistics. Okay, it's a part of spatial statistics. Okay, to be honest, I haven't explored into deep yet. Okay, about the spatial statistics. And I never do the object classification using data mining. Usually I use data only. I haven't used like image, okay, any kind of image or any kind of graphics for this. Okay, for data mining, okay, we can use two-dimensional and also three-dimensional. Nowadays we can also use three-dimensional for the data mining. Okay, so what is the object classification? Okay. Okay, some of the techniques that used in the data mining process include classification, neural network. Okay, image mining and analysis is one of the aspects of data mining. Okay, image mining. Okay, it's not about data only. We can also use image for the in data mining. Okay, so how they use image to in data mining. Okay, we use object classification and recognition have been widely used to conduct image analysis. Image mining analysis is the process of conducting search and discovering information that is valuable from large volumes of data. Okay, this is like image data. Okay, this is image data. We use the object classification and recognition. Okay, usually, okay, there's many, okay, there's many techniques for the image mining. We can apply Bayesian, we can apply association, and and we can also, I read just now, okay, from a paper that we can do like, we can use like regression and other advanced technique, okay, in this. Okay, so usually, okay, in spatial statistics. Okay, yeah. Okay, in spatial statistics, usually spatial is data that have location or spatial data, or we call it as location data. Okay, so object classification is the image. Okay, so okay, usually it is viewed as an object that located in a physical space. Okay, so spatial data, okay, required for main information technology system. Okay, usually they use the geographic information system, or now we can use the GPS, okay, to store information related to geographic location. Okay, so classification in data mining, okay, is a technique that involves in finding models and assigning categories to a collection of data in order to help in better analysis. Okay, so we call it as object-oriented classification or object-based classification. Okay, so it is image mining. Okay, as a statistician, okay, you use software for the object classification. Okay, but we have to specify and classify, okay, what we should do, okay, in the data mining process. Okay, so it's for first it categorize data in pixel based on the shape, or okay, we have any spectral characteristic, okay, or relationship with other pixels in environment and also texture. Okay, categorizing in pixel based on the shape, it means that okay, maybe you can put that some logic function. Okay, if the pixel is between 100 to let's say like 300 pixel. Okay, so will be in first category. Okay, so maybe next is will be 301 until 500. Okay, in category 2, and so on. Okay, spectral statistic means maybe that you want to do like, okay, if they say they have like, you segment it into like square, okay, into a square. So you want to see, okay, in each square, okay, if there's any color or not, something like that. Okay, so this one has color, shader, and this one may be only half, this one may be only like that. Okay, relationship with other pixels in the environment. Okay, so relationship with other pixel maybe, okay, you want to see whether, okay, it has association to other pixels or not. Okay, so we said that 100 to 300, okay, in the 100 to 300, okay, is in this category. Another one is if they have any relationship with 300, 1 to 500. Okay, so it is associated or not. So we can use the independence test, okay, and texture. So how is the texture? Okay, is it like fully shaded? Okay, is it like halfly shaded? Okay, or is it like quarterly like shaded? Okay, so we can do that. Okay, so we're going to learn more, okay, below. Object classification involves making prediction of the classes of object that usually present in an image, okay? It based on data from a group of set of pixels that have similarities. Okay, so we like put maybe a map, okay, or maybe like a brain scan, like brain CT scan, okay, and we do the data mining after that. Okay, this group of pixels is referred to an image object or image object. Okay, the similarities between one pixel and another are usually based on spectral attributes such as color, shape, size, and texture. Okay, so for the object-based classification, okay, it involves segmentation and classification. Okay, so okay, usually in genetic, okay, in bioinformatics, okay, like in science, in weather forecast, okay, they will put like an image, okay, and the software, the data mining will detect, okay, which one, okay, but we have to categorize it, we have to check, okay, like a weather forecast, we will see which is has the like potential to get rain, which one is the dry area and all that. For brain CT scan, sorry, the result of the brain CT scan also the same. Okay, we use the software to do the data mining. Okay, object or image segmentation is defined as a process in which pixels present in an image are divided into group objects or segments. Okay, so let's say, okay, I have a map. Okay, let's say I have a map. Okay, like a map of a lake. Thing like this. Okay, so now, okay, in which the pixel present in an image are divided and grouped into object or segments. Okay, so I want to do, okay, we call it as bounding rectangle. Okay, so I divided into group. Okay, and okay, I do the segmentation like this. Like this. Okay, my drawing is not, no, it's not that good. Okay. Okay, so this one we have the outline of the lake. Okay, and after that we do the this segmentation for this image. Okay, these segments are based according to their similarities in spectra and spatial attributes and characteristics. Okay, object and segments are referred as features, and object or segment can have multiple pixels within it. Okay, during the segmentation process, we can put any parameter. Okay, this one is like the basic segmentation. Okay, but we can also do, okay, the segmentation, okay, depends on the different parameter, okay, to define the process. So which means that, okay, we can do the parameter, this is like the basic segmentation. We can also do like, okay, we want to do segmentation if at least 100 to, let's say, 300 pixels. So we do the segmentation like this. Okay, 100 to 300 pixel. So maybe like this. Or not. Okay, maybe it should be like this. Okay, so 100 pixel, maybe it should be like, something like this. Okay, so it can be, it depends, it will, okay, based on the pixel, okay, on the parameter that used in the scale. The scales of the segment is a very important variable as it is used to define the minimum number of pixels okay, that can be found in a group in order for it to be specified as a separate object. Okay, so we have to define the parameter to do the segmentation. Okay, it can be as simple like this. Okay, and it also can be like as complicated as like this. Okay, next is the classification. Okay, after we conduct the segmentation of the pixel in an image to come up with the appropriate image segment, okay, after that, the object will be classified. Okay, classification takes place by assigning each segment to a class. Okay, this is done based on the features of the segment and the user's the set criteria. Okay, the criteria of classification based on two factors, characteristics of the object or the relationship of the object to other objects. Okay, so which means that, okay, it's not just this object, but the relationship to the other objects. Okay, so we have attributes of the segment that's similar to, okay, first is the size, okay, which is include the area, ratio of the length, and the width of the image. Okay, texture, whether the image has like very smooth or rough. Okay, spectral properties. Okay, we can also find, okay, the standard deviation, okay, or mean of the color, okay, or we call it, or band ratios. Okay, band ratios mean like the color ratio. Okay, we know that when we use some color, okay, when you use color, okay, in the computer, they will code it in RGB, like R red, blue, sorry, RB red, green. Okay, sorry, I forgot the short term name. Okay, but it's like it will be based on the color. Okay, and mean brightness. Okay, what is the brightness of the mean? Is like between the okay, the color. Okay, they will calculate the mean brightness. And whether, okay, if you want to categorize this into class of the shape, whether it's asymmetry or roundness, okay, whether it is like a very have a sharp edge corner, okay, yeah, red, green, blue, yeah, RGB, yeah, red, green, blue. Thank you. Okay, okay, so this one will be then RGB, red, green, blue. Okay, so okay, after you do the segmentation, okay, you can do the categorization based on size or texture or spectral, also the shape. Okay, it depends on you how to classify it. Okay, so if we want to classify image object in a picture, okay, we will find the similarities in rectangular shape object to be buildings and object that were elongated and curly to be roads. Okay, and okay, so let's say this one. Okay, we want to classify objects. Okay, so we find the similarities of rectangular to be the buildings and, okay, elongated objects, okay, or curly object to be the roads. Okay, something like that. So we have to classify. Rectangular is building. Rectangular is, we classify it as building. Okay, and maybe we did have to determine the dimension of the data dimension of that to classify the photo, or elongated. So if you have like unsymmetry or non-linear relationship, okay, we classify this as root. Okay. Okay. So the relationship to other objects. So we have two criteria basis, okay, to classify. Okay. First, the relationship can be, okay, connectivity of other objects. Okay, we can check if a specific object is in contact with other objects. So which means that, okay, so if it is a rectangular, okay, how many rectangular? Okay, and what is the relationship between them? Okay, the rectangle object. Okay, and proximity to other objects. Okay, so we consider the objects that are connected and the distance between the two segments. Okay, so between building and road, okay, what is the distance? Okay, whether it is not dependent. Okay, it is not dependent. Okay, it is independent. But what is the distance? Okay, what is the distance between unrelated, non-connected object? Okay, so okay, we have like a chart. Okay, to illustrate the relationship of the object as a criterion of classification. Okay, consider an image with building and road. So we can classify a segment as a road on the basis that is not connected to the building but creates a link between houses. Okay, so which means that we have a building. Okay, and we have a road. So we classify segment as a road on the basis that okay, it's not connected to the building. Okay, so create the link between houses. Okay, so it means that okay, so we can find the distance between the buildings and also the road. Okay, by using the data mining. Okay. Okay, this is about object classification. Okay, first we have to do the segmentation. Okay, a segmentation usually we only set the parameter. Okay, it based on the study objective, and okay, classification is based on which criteria that you want to set up based on size, texture, spectral, okay, shape, and okay, you can also check the relationship okay between the image and the neighboring image. Okay, um okay, what is the whether it's independent or not. Okay, and okay, it is for the independent, okay, so we can also find the distance between the unrelated objects, okay, after we do the segmentation. Okay, so any question for object classification? Okay, no. Okay, so let's begin with image mining. Okay, so image mining, okay, is after we done the classification, is like details about the, after we do the classification, segmentation and classification. Okay, it can be defined as a technique of data mining that is used to conduct data exploration, okay, dependency on in the image data and extract patterns that are found in this image. Okay, so when we do like image, okay, how we're going to do the data mining. Okay, we do segmentation, classification, okay, and after that we check the dependency, okay, with the connection between the neighboring image, between the segmentation, between the neighboring segmentation, and okay, and we also find what is the distance between like non-dependent like neighboring segments. Okay, so we want to extract patterns that are found in the image. Okay, so the main aim of data image mining, okay, to find significant and reasonable pattern of the image without exactly knowing the content of the image. Okay, so we know the study objective. Okay, we know that what we're going to find out. Okay, but okay, let's say I don't have any idea about the result of the weather forecast today. So I let the data mining do my task based on what segmentation and classification that I have set up. Okay, so there's two basic techniques, okay, for image mining. Okay, first is conduct the exploration on various pictures that are independent. Second is to carry out the technique on images that are linked and integrated to each other. Okay, so first, okay, we do exploration, okay, on many image, okay, that is independent, so unrelated at all. Okay, so we do the exploration. Okay, second technique in image mining, okay, so we do the uh, analysis, okay, we do the analysis, okay, when we have an image, okay, that is dependent to each other. Okay, so it's similar to each other. So we also carry out analysis, finding whether it is significant or not. Okay, so okay, image mining can be conducted in two main processes. Okay, manually, which will detail fragmenting and cutting down the data to achieve specific pattern, okay, or automatically by performing the technique using computer program. Okay, so usually you have an image. Okay, so you do manually fragmenting it. Okay, you do it into like a square or rectangle, or we let the computer programs doing it. Okay, so I taught mathematical graphics last 2 years. Our last 2 years. Okay, so in mathematics, okay, I also don't know. Okay, I never learned it before, so I'm learning when I'm teaching my student. Okay, we do the I don't know whether any of you are mathematicians here, okay, but if it is like pure mathematics, you do the image, okay, something like data mining, but based on the model. So we do the Julia, okay, let me show you. Okay, let me show you. Okay, let me show you. It's like application of image mining, but in mathematics. Okay, let me show you. Okay, so we do data screening, not data screening. We do like, we set the parameter, the formula, okay, by using this one, the Mandelbrot sequence, Mandelbrot set sequence or Mandelbrot set, this one, okay, by using graphical. So how they are going to, okay, and also, let's see. Okay, this one is Julia set. Okay, Mandelbrot Julia set. Okay, we do the parameter estimation based on the like image of this. Okay, this is a Julia set. Okay, you can see this one. Yeah, I do something like this. Okay, this one is Julia's, this one slice animation. Wait, let me show you the number. Yeah, here. Okay. And also Mandelbrot. So, yeah, so this is Mandelbrot, more like round. Okay, and it will create like a child here. Okay, so it is something very, very like interesting to me because, okay, it is very interesting to me because I'm not a mathematician, okay, but I got to learn it, okay, I got to learn it when I'm teaching my students, okay, about the Mandelbrot and also Julia. Okay, so we do the formula, and we do the formula and we make a graphical based on, yeah, on the Julia. Okay, it's like, I don't know how to describe it, okay, but we do the graphical and also we set the parameter based on the Julia and Mandelbrot set. Wait, let me share my screen. Okay, the primary basic described in an image mining are color, texture, and shapes of the object. Okay, so, okay, image mining based on color, texture, and shapes of the object. Okay, using these primary describers, okay, researchers and data analysts, okay, able to identify and extract image that are similar from a database of image. Okay, so if you use manual, okay, it's very difficult to do because first, okay, we deal with a large data set. Okay, so if you use the software, it will be okay. So we can set the shapes. Okay, like RGB, using the RGB, red, green, blue. Okay, so what is the code? Okay, between the range. Okay, then they will classify in one category. Okay, if this category may be like between red, green, blue, between maybe 300 to 315, okay, so they will be categorized in one group. So when we run, after we do the segmentation, when we run a lot of data, because the segmentation, okay, if we have like a map, okay, so we do like a very, okay, a very small segmentation. Okay, it's hard for us to do it manually. Okay, it's hard for us to do the manually. Okay, so we set the, let's say if I want to use the color, okay, so I set the RGB in category 1 is category 1, category 2, category 3. So RGB may be between like 000 to 0, 0 to let's say um, 050, something like that. Category 2, RGB between 051 to 100, something like that. Okay, so based on this, the data mining we check by every segmentation here. Okay, whether this one is maybe white color, right? So zeros. Okay, so if it's white color, okay, which is belong? So maybe belong to this category. Okay, this segmentation, okay, maybe belong to this category. So then we do the categorization. Okay, after it base all of the image has been classified. Okay, after the image has been classified using color and everything. Okay, so we do the test of independency between category 1 and category 2. Okay, we do the test of it, whether it's associate or not. Okay, category 2 and category 3. Okay, we do. We can do many things. Okay, and after we do all the segmentation here, we can do association, we can do the time series, we can do regression, we can do a lot of things. Okay, we can see whether we can come out with a different kind of outcome. Okay, from the image itself. Okay, using these primary describers, researchers and data analysts, okay, able to identify and extract image that are similar from a database image. Okay, this is often difficult to push through using manual methods, and the method also time consuming and inefficient. Okay, more automated methods have been used in the recent past to conduct image mining, and they have proved to be very valuable. Okay, but the thing is you have to set the parameter, and you have to set the classification and do the segmentation properly. Okay, if not, okay, the image mining will not work as you wish. Okay, it's a bit lagging. Okay, yeah. Okay, so we use machine vision to retrieve image in digital formats from large data set. Okay, one of the common method is content-based image retrieval. Okay, so every image that found in a database has particular attribute that is used to conduct a comparison to a query image after extraction. Okay, so it means that, okay, they will see whether it is a similar, has similar attribute or not. Okay, something like this. Okay, so this is the architecture of content-based image retrieval. Okay, first we start with picture query. Okay, and we describe the visual concept. Okay, then we like decide what is the feature vectors. Okay, compare the similarity. Okay, and okay, and second one, okay, we can also using the database image. Okay, image in the database. Okay, describing what is the visual concept. Okay, from the database, so we create a database features. Okay, so we can compare, okay, the one in the database, okay, and also the one that you do and we can compare the similarity. Okay, so this is from the database. Okay, this is from the new image that you do it. Okay, so we do the visual concept. Okay, and this one also in the database, we describe the visual concept. Okay, then from a database and also from the new photo, we compare the similarity. Okay, we compare the similarity. We do the indexing and retrieval, okay, like the categorization or, okay, the classification. Okay, and we do the like association also. Okay, then we retrieve the result. Okay, then we get the feedback, then we we get the result and output. Okay, if you, let's say you want to set it again, okay, maybe we want to get like feedback, okay, from the result, we can do the feedback and compare the similarity again, then come out with the output. Okay, there's many ways for you to do this. Okay, actually, this is like one of the method. Okay, so okay, before we start with the segmentation and also classification, okay, we also involved with the pre-processing. Like in data mining, okay, our pre-processing is we have to check for the missing data, outliers, like any null data, right? Okay, any null data. But in image, we also have that, okay, but okay, it's a bit different, which okay, to improve the image quality before conducting the actual process. Okay, this in turn help the extraction of the attribute to be easier and reliable. Okay, so for data mining, we check for the missing value, outliers, null value, right? But in image, we check the image quality. Okay, so usually, okay, they are focused on image property. Okay, so let's see. Okay, let's say we have like this. Okay, so after we do the segmentation here, so okay, okay, we can do the filtering by, okay, maybe I don't want the part that is like empty with only the white color, the white colors, sorry, not white color, like yeah, RGB in 000 and 050 will be filtered out. Okay, so I don't want to analyze that because first I want to reduce the data dimension that I'm going to use in the data mining. Okay, so we do, so we filter it out. So we filter out, okay, any color RGB 00 to 050, we filter it out. Okay. Okay, so this help in enhancement and change in the image by highlighting some of the features in the image. So we only focus for other features in the image. Okay, linear and non-linear filtering methods such as low pass filter, band pass, and high pass are some of the filtering methods that are used in removing noise that exists in the image. Okay, other than by colors, we can also use like linear or non-linear filtering method. Okay, so what is the filter band pass? Usually we put like, okay, what is the texture look like? What is the RGB code? Or maybe we can do like, okay, usually we just do the ratio. Okay, but we can also have like, I saw that in one paper, they use the Bayesian. Okay, they use the Bayesian. So if the image probability, okay, they use the parameter for the Bayesian. If the image is not belong to the Bayesian parameter, okay, so they will just discard it. Okay, after we cleanse all the data that have poor quality, okay, that has low quality, that are like some of this, like only the noise, okay, exists in the image, or maybe it just like it's a distorted image. Okay, we clean it up. Then after that, we can start with the classification. So classification, grouping data in an image using pixels and attributes. Okay, so we have two phases in data mining classification. Okay, the learning phase and the test phase. Okay, learning phase. Okay, in the learning phase, there is a distinction in the profile image, and learning is made based on the class. Okay, so in learning phase, you set up, okay, you give the computer to understand what you are going to do. Okay, so after the computer understand what you're going to do, okay, so you can carry out with the data mining. Okay, so what is it? Okay, in the test case, some of the specification part are used to classify the image. Okay, usually we use SVM, is a SVM-based classification rule, neural network, and fuzzy logic approach. Okay, so usually we use all this. Okay, so some of it. Okay, okay, some of it. Okay, classification rule, neural network, and fuzzy logic approach. Okay, actually we can, this one you can use using the software. Okay, you can use using the software. Okay, but okay, what is the tree? Okay, let's say I have a rectangle here. Okay, and I do the segmentation first. Okay, I do the segmentation. So yeah. Okay, so after that, okay, I splice it up. So to make it like this. So it will be, so each okay, every this, okay, I will create from 1 to 0 to become 43, and after that become more. Okay, so this is like another example, like for the decision tree. Okay, so from this, okay, they will like, okay, uh, like exploring. They will like narrow, sorry, not narrow down, expand down, okay, into more detailed image. Okay, SVM is actually the SVM is, let me find the, what is SVM? Okay, using the support vector machine, okay, based on classification, neural networks, and fuzzy logic approach. Okay, to be honest, I never use SVM, okay, and I never use fuzzy logic approach, okay. I use only neural networks. Okay, and after we do the classification, okay, we do color processing. Okay, the use of a color histogram is one of the major method color processing. Okay, the color histogram of an image can be defined as the representation of the color distribution. Okay, we use RGB color distribution. Okay, so what is the average of red? Okay, what is the red pixel, or we call it spotted pixel in red, and green pixel average blue. Okay, so the color image red, green, blue RGB, okay, is a M by N by 3 array of color pixels. Okay, the color pixels is a triple that specifies amount of red, green, and blue parts of an image. Okay, you can use the RGB code. Okay, RGB code. Okay, you can just find it in, okay. So let's say I want one white. Okay, so I know that white is, red is RGB. Okay, so red is 255, green is 255. Okay, and blue is also 255. Okay, so 255 times 255 times 255 times 255. Okay, so you will get what is the RGB color. Okay, what is the RGB color? Okay, so let's say I want 255, 255. Okay, so what is the RGB color? Okay, so usually, okay, wait, let me share you the screen. This is how we calculate the RGB code. Okay, so this is a RGB color code chart. Okay, so let's say I want to find the let's say the basic one. This one, right? Okay, so red is 255, green is 255, blue is 255. Okay, so we have like two. This one is, okay, this is other color. Okay, so we times it, so we get, okay, so we know, okay, what is the, let's say, white RGB color, okay, and 255, sorry, times 65526, okay, you get this as FFFF. Okay, blue RGB code, okay, this is like, there's many methods to find the RGB, but this is how is it, okay, in your notes also, okay, other, okay. So let me share again. So the color pixel is a triple that specifies the amount of red, green, and blue parts of an image. Okay, so sorry, I jumping around my screen because I have a lot to share. So yeah, I use books, I use journal, and also I use Google. Okay, and after we also do color processing and also clustering. Okay, image mining activity that involve dividing samples, okay, into groups with similar characteristics. Okay, so we do the image mining, but based on clustering. Okay, this group are formed, we call this as cluster. Okay, the criteria for use for cluster is either distance-based cluster, okay, where two objects are clustered in accordance to the closeness to each other, or based on two or more objects are grouped according to the similarities in attribute. Okay, so you can set up the cluster, okay, based on distance base or whether it has similarities in attributes, okay, which means that by color, by texture, okay, by bandwidth or by brightness or by standard deviation or mean. Okay, clustering is performed object dividing them into a number of cluster of subset that are the heterogeneous population is known to be homogeneous. Okay, so after we do the clustering, okay, and we divide them into number of clusters, okay, there are heterogeneous population, we call this as homogeneous. Okay, I show you how the cluster data mining is. Okay, so this is like clustering, okay, using the image mining. This is K means, okay, it can be like this. Okay, for image mining, okay, in image mining, okay, it seems like a data mining, but we have to do, like I said, the segmentation, classification, then we carry out with the clustering, okay, this one also, okay, and we can see that the clustering, okay, we can provide the cluster, okay, if you want to set it based on attributes or based on the distance, okay, based on the distance. Okay, next is feature extraction. Okay, conducting feature measures of an image, the basic and identifying, distribution, and categorizing an image. Okay, extraction of the properties of the image. Okay, for the purpose of decision rules development, conducting of analysis and diffusion of the observed image is done by the machine vision research by providing object models and the image scene. Okay, image technique developed in accordance with the image revival system based on content. Okay, some of the visual contents of an image that form the base of image technique, okay, like the styles, texture, color, shape, and arrangement. Okay, correct selection of those characteristics and properties will ensure that there is a presentation of useful information about the object, and the method of feature extraction conduct analysis on the image, objects, and properties to ensure extraction features significant, thus depicting the different object classes. Okay, so like features extraction is, okay, usually you have to specify, okay, what you're going to do the features extraction, whether it is like based on texture, based on shape, or the arrangement. Okay, so let's say if you use the texture, can be, okay, texture. Okay, so the texture is the structured arrangement and the data pattern that are seen in the image. Okay, so whether it is more, okay, so you can set how is the smooth range, okay, what is the rough category. Okay, so grouping the features that are naturally available on the surface make it commonly used feature in the processing of the image. Okay, it does not depend on other features such as colors and includes information that shows arrangement that are defined and structured in an area. Okay, so very easy to distinguish between objects using structure without any other additional data. Okay, some of method of conducting image texture. Okay, we use Gabor filters or we use fractals and also microwave converter socialization. Okay, some of the parameters that can be extracted using image texture. Okay, the homogeneity using the homogeneity, average, mean, standard deviation, contrast, entropy, and correlation. Okay, so what I just want to do okay, the feature extraction. Okay, from the image. Okay, you can do the feature extraction based on the texture. Okay, based on the texture. Okay, so you can like categorize the your image, okay, based on the texture. You can also do like other features. Okay, maybe you want like a sharp corner or like a straight line, or maybe you want to do the feature like it is like block color, okay, or lightly color or pastel color or all that. Okay, that's a feature expression. And okay, we can do a property selection. Okay, so measuring, okay, this one is more like, and it's more towards the analysis. Okay, now it's better. Okay, property selection. Okay, measuring method that are used to conduct property selection. Okay, so we use gene index, gain ratio, chi-square. Okay, I only use chi-square. Okay, so chi-square, okay, merge discretization, cutoff point, and discretization base applied to conduct discretization. Okay, so we know that chi-square, okay, chi-square is observed minus expected square over expected, over expected. Okay, so the discretization method are used to create intervals during the making decision tree that are usually depend on what ways are used during, okay, this discretization process. Okay, features and property selection ensure that there is a reduction of the dimensional problem, okay, and in turn reduce the calculation of time and improve prediction. Okay, removing features that are unrelated and noisy will remove problems in image processing and some of the algorithms that used to conduct properties. Okay, sometimes we use sequential forward selection, sequential backward selection, branch, and genetic algorithm. Okay, for this, okay, I just want you to know, okay, I will not emphasize more, but okay, for the property selection here, okay, sometimes we use a chi-square, okay, whether the image is related or not related. Okay, and after that we do the, because the chi-square, we test it in pair. Okay, we test it in pairs. So whether if it is in related, okay, so we find out whether it is significant or not, and we find, or maybe we can find the association between the image. Okay, and sequential forward selection. Okay, then we do, okay, one pairing by pairing. Okay, by using data mining. Okay, or okay, we do everything by, if it is sequential backward selection, okay, we find the whole significance. Okay, then we eliminate it one by one. Okay, same like regression. Okay, this one I just want you to know. And for the genetic algorithm, okay, we find, okay, whether, okay, if it is related to which like pairing that is related to each other. We do independent and also the non-dependent. Okay, so another one is histogram equalization. Okay, this method performs the setting of contrast in image processing. Okay, so we set the contrast in image processing. Okay, so the image amount of contrast is divided on the histogram using the setting. Okay, and any image that contain background and foreground, okay, we have to like filter it out. Okay, so then after that, after we do the histogram, the contrast, okay, the histogram. Okay, so severity, then after that, okay, we categorize it maybe here, how many, okay, using the contrast of the image processing. Okay, one of the application, they use a severity histogram, okay, like in, usually for the, actually, I don't, I think histogram equalization is more towards like traditional method. Okay, nowadays, clustering, okay, clustering and, yeah, clustering and the classification is more popular to use. Okay, because the histogram equalization we can just easily access if you want to find from the like standard deviation or the mode, or maybe you can use the okay, find the mode, and also we can find the chi-square. Okay, so it's not that popular in image mining. And to be honest, I did not find any like recent research paper that uses histogram equalization, okay, for the image mining. Okay, that's all for the image mining. Any question? Okay, if you don't have any question, I want to ask you, have you decide, okay, which day that you want to do the replacement class? Okay, I'm open from, we have to set up like very fast because I have to inform Uniraza, okay, and they want to set a Zoom for me. Okay, it must be on weekdays, one for midterm and one for 1 hour class. Have you decided?
Prof. So actually, we have
Can you
the
discuss among yourself? Do you have any class representative here? Do you have any class representative here? No?
No, we don't.
No. Okay, it's okay. Please discuss it with me. Yeah, you have to discuss it like very fast. Okay, because if not, yeah, things happen, right? Actually, we already planned it. Okay, now it's very hard to find a time. I know that you are busy with the research methodology. Okay. And okay, please like decide when, then email me so that I can inform with to the Uniraza. Okay. Okay. After you decided about yourself, please let me know. Oh, 5 February. Yeah, fine. 5
Yeah,
February
maybe
is
on the fifth, on the fifth
Monday.
February because
Monday next week, right?
yes,
I can. I can. 5 February evening. 5 February. This is for class. I think better we do like for 3 hours straight, right? I try to do your midterm only for 1 hour and a half. Is it okay? So we can do class 8:30 until 11. Okay, so I will try to do your midterm only 1 hour and a half like that. 1.5 hours. Your midterm.
can
Still lagging. Okay. Is it okay? Can do straight, right? Okay, I try to do your midterm 1 hour and a half. So our class on 5 of February, 8:30 until 11. Okay, 8:30 until 11. Okay, so I do 8:30 to 11 p.m. Okay, so it will be 1 hour class. This will be 2.5 hours, right? Okay, so I will do 1 hour class. 1.5 hours is for your midterm. Okay, is it okay? Okay, is it okay? For your midterm, okay, for your midterm, I decided to do like section A and B. Okay, I do want to do like section A and B. Okay, section B is essay. Okay, section A. Okay, section A is okay, yeah, I think like something like short and question that we did before. Okay, short question. Okay, it can be multiple, true, false, matching, and classification. But this time around, okay, I'm not sure how Europe's do the marking. Okay, but if you have any like issue, you just let me know. Okay, maybe this time around I will reduce the error. Okay, maybe I will reduce the error by using true, false question and fill in the blanks only. Okay, fill in the blank, but you can choose um, the answer. Mesh configuration. What mesh configuration? Oh yeah. I already used the like evening time, yes. 8:30 until 11 p.m. This one is Monday. Okay. So 1 hour class, then after that midterm. Okay. After that midterm, we have set quiz A and B, 1.5 hours total. Okay. So you can begin with section A with short question, then follow with section B, essay. Okay, it helped me to mark faster. Okay, it helped me to mark faster. Okay, you do short question, then follow by essay. Exam tips. This one is on 5th of February. I give you next week. Okay, I give you next week. Okay, what cover in midterm? Okay, what cover in midterm? It will be from chapter 1 until next week. Okay, chapter 5. Okay, chapter 1. No. I think I want to reserve chapter 5 for your final. Chapter 4 only until today. Okay, we cover chapter 1 until chapter 4. Okay, so it will be yeah, okay, 1.5 hours on Monday. Okay, on 5th of February. Okay, your task today, okay, please listen. Okay, so this one will be your will contribute to your case study. Okay, today, okay, it will contribute to your case study. Case study is around 25%, if I'm not mistaken. Oh, I can't remember the ratio. Okay. I want you, okay, later, this is like brief. Later, I upload it in Europe. Okay, this is only brief. Later, I publish it in Europe. Okay, I publish in Europe. Okay, your task this week is you have to find one research paper about image mining. Okay, about image mining. Okay, it can be in any field, biology, science, medical, okay, environmental, anything, okay, anything. It can be in a finance, banking, economy, okay, or like maybe social science like accident and all. Okay, find one research paper and do okay, summary for the paper. Okay, do the literature summary for the paper. Okay, make sure the literature summary, you have to highlight, okay, what is the objective of the paper, what is the method that it used, and what is the conclusion of the paper. Okay, please write it in 100 to 200 words only. Okay, 100 and 200 words only. Okay. 120, yeah, it's decent enough. Okay. So you have to highlight what is the method in the image mining used in the paper. Okay, and what is the conclusion of the image mining? Okay. I know you are MBA student, you don't have to go further on the critical part. Like if let's say they use like maybe they use some of the paper that I saw that they use K cluster like Bayesian. Okay, you just have to mention it without like go further on the theoretical part. Okay, I just want to find to understand. Okay, so what is the method, image, and conclusion? Okay, you have to submit to me in two attachments. One is your summary paper. Okay, and you also have to submit to me the research paper that you use. Okay, it must be published, research paper. Okay, it must be published. Okay, and it must be, you cannot find like, it must be a published paper. You can find it in journal article, or maybe you can find in any conference proceedings paper, or like any published book. Okay, please avoid that find in like the one that is not published, like in Wikipedia, like in any like, okay, like in any like Google's that like, please publish an academic research paper. Publish academic research paper. Okay, do a summary 100 to 200 word that related to image mining. Okay, so later I will this is like only brief. Okay, later I will upload in Europe. Okay, so you have to submit to me in two. One is the research paper that you use. Another one is your summary. Okay, please convert both in PDF. Okay, okay. Just do a paper review. Yeah, this is called paper review. Any question? Okay, later I write it. I post it in Europe. Okay. Oh, paper due. Sorry. Okay, paper due is next week. Today is 27. I give you 1 week to do. 2nd of February. Okay, 2nd of February 2024 by 5 p.m. Okay, deadline. So you have 1 week to do. Okay. Any research paper, yeah, published paper. No. It can be old. Yeah, it can be old. Okay. Yeah, I saw that many of the image mining, okay, usually they do on 1999, 1999, okay, before 2000, yeah, it's okay. Okay, I just want you to highlight objective of the paper, method, and also the conclusion. Okay, no preference. Okay, but you have to attach to me the paper that you use. Okay, please avoid using the same paper, because I want all of you to have like different academic research paper. It's just not can be, it can be anything. Okay, as long as a published paper. Summary based on paper or need to relate with data mining topic. No, I mean that the paper that you're going to find is must be related to image mining. Image mining. Okay. Yeah. So you have to find the paper that relate to image mining, then do the summary. Not data mining topic, or image mining. I have narrowed down. Find the paper that relate to, okay, let me show you. Okay, one of the um, paper that I got. Hold on. Web mining. Okay, here, deforestation, page 55. Okay, this one, they use image mining based on for the deforestation. Page 55. Okay. Hold on. Page 9. Hold on. Okay, this one. Okay, this one is using image mining. Okay, for the deforestation. Okay, you see that. Okay. Okay, they use remote sensing and image mining. Okay, how they use image mining in deforestation. Okay, here, image processing. Okay, so I just want you to find the summary. Okay, detecting deforestation pattern through satellite. So they use the satellite photo, okay, and find using the spatial pattern. Okay, so the geometric structures extracted from the image using techniques for feature extraction. They use feature extraction, segmentation, and image classification. Okay, they must be identified and labeled according to a typology, which expresses, okay, so this is like define the image mining based on the classification. Okay, and after that, okay, they build restaurant data set. Okay, so this is like from the database. Okay, the deforestation photo. Okay, so they do the segmentation. This is a satellite photo. They use the segmentation. Okay, and okay, they use this software. Okay, and this is the method. Okay, and this is they do the which they detect where is the deforestation. Okay, so this is another like example of image mining. Okay, so that one is one of the example. Okay, so you have to do the summary. Okay, based on the image mining paper, published academic paper. Okay, and submit to me the between write it in 100 or 200 words. Okay, and submit to me the paper and also together with your summary. Okay, I give you 1 week to do. Okay, submit to me by 2nd of February. Okay. Okay, I think that okay, neural networks. Okay, neural network is okay. I use a bit of neural networks in my PhD. Okay, I call it as graphical modeling. Okay, it's actually a type of neural network. Okay, so usually we have okay, neural networks in data mining referred to as a model of computing and information processing that is used in identification of the critical relationship between a pattern or a set of variables in the data. Okay, usually neural networks, we don't use image mining. Okay, we don't use image, it's a data. Okay, so the powerful model of recognition of data pattern has led to the popularity of neural networks in field of data and image mining. Okay. Oh yeah, you have been used in also in image, but so to be honest, okay, it's more common in data. Okay, it's more common in data. Okay, we have a convolutional neural network. Okay, it's an architectural of neural network that have powered the concept of image recognition and image mining. Okay, convolutional neural network mimic the breaking down analysis of data in an image by the visual context. Okay, and image recognition is a technology that uses AI to identify and distinguish places, objects, and people in an image. Okay, the convolutional neural network created to critical and effectively process, correlate, and have understanding of the large amount of data in high-resolution image. Okay, neural network image recognition helps machine vision system analyze the physical object, features of the image by first extracting the image. Okay, it seems like okay, it seems like the one that we talked before, okay, the one that we talked before, but for the neural network, okay, so we use first, okay, same, okay, we do the image recognition, okay, objects and features of an image, okay, we identify the features of an image, extract the image, okay, and the properties that are important, then organize the data through classification and feature extraction. Okay, same like previous one, we also have the pre-processing. Okay, we have to be honest, I never use neural network in image mining, but I use neural network in data. Okay, so but for the data image mining, okay, same like previous. Okay, so we scan it. Okay, and then we extract the image properties, then organize the data using object classification and feature extraction. Good. Arazi? Okay, so the machine vision system can finally use algorithm and classification to come up with decision on the image categories and description. Okay. Okay, after we do the extraction, okay, we can decide for the what is the categories and the description. Okay, neural network image recognition algorithm. Okay, so the common types is image classifier. Okay, so image classifiers inputs an image and conduct prediction of the contents of the image. Okay, the output of prediction is presented in a form of class label. Okay, and okay, we train the image recognition. Okay, so that they understand and differentiate between different classes. Okay, so we let the computer, okay, in the learning, okay, in the learning phase, similar like image mining. Okay, we train our software, we train our computer to understand, okay, about the okay features in the image. Okay, to so that they will know how to differentiate different classes. Okay, so let's say if you want to identify image of donut, okay, so you train your software, your neural network, okay, about a multiple image of donuts, okay, and other photo that do not have donut, okay. So you train your neural network to do it, okay. So when you train it, okay, so if you put a bunch of image, okay, if you put a bunch of image, so your neural network will know that it's not donut or it is a donut. Okay, so this image recognition algorithm will understand to extract the properties that can distinguish and identify a donut object and can effectively classify the image that have the object donut. Okay, so another image recognition that I use in recurrent neural network, okay, to perform complexity is to make caption that contain a description of an image automatically. Okay, other than you, okay, that one is called like recurrent neural network. Okay, so okay, we perform complex activity. Okay, okay, this algorithm is used to perform complex activities and is used to make captions that contain a description of an image automatically. Okay, so whether it is a donut or is not a donut. Okay, so in a neural network, it's same like image mining. Okay, it's same steps like image mining, but just a different technique of that. Okay, so first we have to come up with a good neural network image recognition algorithm. Okay, so we need a quality data set that contain image used to train and test the algorithm. So you have to provide the neural network with many photo, image of, let's say, the previous one example is donut. Okay, so other than that, okay, we can also preparing some parameter, okay, when parameter in the image data. Okay, so what is it? Okay, the first concern is like the number of image. To ensure the accuracy of the neural network, okay, it's important to okay, to supply, okay, with your neural network, okay, with a lot of image. Okay, and after that, okay, accuracy of the algorithm is in the information given. Okay, so okay, you need to provide okay high quality image. It's not just the number of image that you supply, you also need a high quality image. Okay, so that your neural network can understand okay what is what they are learning, okay, before they can make a decision after that. Next is okay, you can also have a mean and standard deviation of input data. To obtain more information on the properties and image structure, we can conduct to find the mean and image by getting the mean values of the pixel in the training data. Okay, let's say, okay, you can find like maybe the let's say the pixel, okay, of the data. Okay, so let's say if the pixel must be like maybe you set it like maybe 300K pixels and above to be accepted. Okay, so you train the neural network so that okay they only analyze the image okay if it is like 300K pixel and above, something like that. Okay, so and you can also specify the standard deviation of the image. So the standard deviation of the image in the pixel must be okay below 500, let's say. Okay, and another concern is the aspect ratio. It is important to ensure that image have a similar aspect ratio and size, since neural network algorithm assume that the input image is square-shaped. Okay, so in order for us to supply the image for the neural network, okay, we must ensure that the image have similar aspect ratio. So, okay, so because it is assumed it is square shape, okay, so we have to do some modification in the image that you supply to the neural network. It must be in the aspect ratio. It must be in this dimension. Okay, it must be in dimension. Next is number of channels. Training the model with multiple channels. Okay, multiple image channel. We have the identification. Color image contain 3 color of RGB, while grayscale image have 2 color of black and white. Okay, so it just not the Okay, you have to train your neural network model. Okay, with many channels. So it can be color or it can be in grayscale. Okay, it can be in, usually for the image mining and neural network, we use 2D and also 3D. So you have to train the neural network in different aspects. Okay, what color, what texture, okay, and it must be a lot. The size must be for high quality. Okay, the mean of the pixel must be in this range, within this range. The standard deviation must be within this range, and also it must be the modification must be in a relevant ratio. Okay, and after that, okay, we can predict the model. Okay, the image of we can predict the model based on the image. Okay, so neural networks are a collection of nodes that are interconnected to each other. Okay, as neurons. Okay, so it's okay, in neural network image recognition, each neuron input 1 pixel of the image, carries out computation called the activation function to come up with the result. Okay, the numerical way each neuron affect the result, and the prediction of every input of pixel is made at the end of the process after the result have been inputted or other neural layers. Okay, so let's say we have like, so they will, okay, whether it's in category 1 or category 2, and after that, okay, something like this. Okay, based on the pixel. Okay, propagation is a process where the neural network get to understand the appropriate weights of the neuron that leads to the accuracy of the prediction after the repetition of the initial process over a large data set of image. Okay, to test the accuracy, the model is given a new set of image that were not used in the learning process, and we check the success of the accuracy test, okay, whether the model is ready to be used or not. Okay, so after we supply during the learning time, okay, then we test whether the neural network understand, okay, our task or not. Okay, whether our task or not. So we have to, okay, check. Okay, so the neural network, we put the category, okay, which the image. So maybe this image is belong to the category uh, like the paper that we selected before. Okay, if we use neural network for the deforestation, so which means that, okay, this segmentation doesn't have any for deforestation. Okay, let's say this is the picture of the forest, okay, by using satellite. So they put the segmentation, then do the Okay, then we teach the neural network to understand, okay, what is the deforestation. Okay, so there will be maybe one, no deforestation. Okay, so we categorize it. So deforestation, no deforestation means, okay, maybe the color of the square, okay, is totally green. Okay, like maybe this one is light deforestation. Okay, we categorize it as like maybe only 10% of it with the green color. Okay, so it's maybe like medium different. Okay, so medium maybe it is like okay, almost like covered like quarter, more like half. Okay, so this one is like heavy deforestation. So which means that it might be in, let's say, like darker green color. Okay, maybe it's in a darker green color. Okay, so the neural network will do based on the categorization. Okay, so we can also set up based on mean, okay, by using pixel, okay, or you can also find using like standard deviation. And before that, okay, we can use that different in different channel in whether in color or in grayscale. Okay, so but okay, and after that we can test whether it is accurate or not. Okay, we test for the usually we do a pilot study. Okay, then we test it first. Okay, and what is the disadvantage of the regular neural network used in image recognition? So sometimes it is overfitting, okay, because of the many parameters. Okay, the model process is intensive because, okay, to convert into the like many image, okay, segmentation and the classification, set the parameter, okay, is time consuming, okay, and it takes a lot of process involved. And the result may be difficult to interpret and debug. So that's why from the beginning, we have to clearly state what is our study objective and classify and do the segmentation properly. Okay. Okay. The disadvantage of convolutional neural network, okay, too much process power needed, and chances of failure are high when there is a slight tilt or rotation. Okay, let's say you have a poor quality, okay, and your like image is like low pixel, okay, and it's like and suddenly you have like a rotation tilt, so they cannot process your neural network properly. They cannot do the modeling of the neural network properly. Okay. Okay, I have finished neural networks and also the image mining. Any question? Any question? Oh, by the way, some of you asked whether you can find like any research paper for image recognition for neural network. Yes, you can also find it. Okay, but any academic research paper that relates to the data and mining in using image and also neural network. It can be anything. Any question? After this, I will publish the task of your okay, for your next task, okay, for your next task, I will put it under case study. Okay, I will put it under case study. Under case study. Oh, Wong Shipin and Mukmin, I already adjust your marks. Okay, you can check it out. Okay, so I repeat again. Class replacement will be on 5th of February. Okay, it will be 2 hours and a half. Cover chapter, okay, midterm will be 1 hour and a half. You will have section A and B. Okay, section A is short question. Okay, it will be matching. It will be like classification. Okay, I will try to improve error. Okay, in this the previous one is actually my first try, so bear with me some error. Okay, essay question for part B. Okay, and also but we begin with our usual class for 1 hour. Okay, on 5th of February. Tips I will share in next class. Okay. Okay, for your midterm, okay, I will invigilate. Okay, for midterm, I will invigilate. So you have to open your camera. Okay, and yeah, you have to open your camera. Okay, it will be 1 hour and a half. Okay, so for your paper today, okay, it will be our like paper review, class first. Class first, yes. I will start with class first, then follow with the midterm. Let's say if our class end earlier, we can start away your midterm. Okay, can start away your midterm. Okay, so for your paper, find one published article. Okay, and write a summary from 100 to 200 words. Okay, so in your summary, okay, yeah. I will check it. Okay, I also saw many of you have. Okay, I will check one by one and let you know. Okay, I will post an announcement after this. Okay, objective. I will let you know. Okay, for your summary, when will today's lecture recording be uploaded? Because the midterm covers it. That one I also don't know. Okay, sorry, Vicent. Okay, I think that after 24 hours, the recording will be online, right? But I'm not sure. Okay, I'm not sure why sometimes it is late. Okay, why sometimes it is late. And actually, I also don't know where they share it. Okay, I think it's Eurox, right? Okay, I will let you know. Okay, so the published paper, after this, I will publish the instruction of your, it's not that it's easy. You find a paper, write a summary and the review, but your summary must include objective, method, and the conclusion. It can be any image mining method and neural network based on image mining. Okay, and you have to attach two things, the research paper that you use in your oh, you need to check the SKC YouTube. Oh, okay. I also don't know. Okay, usually I don't rewatch my recording because after I watch it, it was like, I should do better. I should do better. And it made me feel bad. Okay, I don't know. Okay, so the deadline will be 2nd of February at 5 p.m. Okay, this one, 2nd of February is Friday. Friday. Okay, so you can start doing it now. Find any article. Okay, write a summary. It's not much, but you just have to understand the article. Okay, it's related to image mining and neural network image mining. Okay, I will publish it after this. Okay, any question? Any question? Okay, don't worry. I will check one by one. Okay, and update you by tomorrow about your short-term question because some of you okay, some of you will okay, request me to check question 1. Okay, maybe I should like improve after this. Maybe I just use true or false, so it's easier to like find it. Okay. Any question? Oh, not yet. Okay. Okay, this review paper, I will put under case study. Okay, this one is 15%. Okay, for your assignment, I already finished marking your assignment. So just give me, but I want to recheck it again. Okay, I want to review it again. Okay, and before I email it to you. Okay. Okay, okay, if there's no question, okay, anything you can email me. Okay, but for the short-term question, I think I will do it after this. I will do it like maybe like for everyone, I will like finish doing it tomorrow. Okay, and after this, you can check I will publish the case study question in the Europe. Okay,